All right, now we're just going to show you a few different examples that any of these shortcuts could apply. So we want to simplify this down. Remember, we can rearrange any of our pieces together. So I'm going to keep my numbers together. So I'm going to do 4 times 7. I'm going to keep my x's together, x and x squared, and keep my y's together, y cubed times y cubed. All right, and then from here we can simplify. So 4 times 7 is just 28. I can use my shortcut here, or if I don't remember, I can expand and do x times x times x. But remember, our shortcut, and I'm multiplying same basis, I can just add them together. So remember, this is like a 1. So 1 plus 2 is 3. So this would be x to the third power. Same thing here. I could write out 3y's and being multiplied and 3y's being multiplied, or I can just use my shortcut here where I can just add them together. 3 plus 3 is 6. So my simplified version of this would be 28 times x to the third power times y to the sixth power. All right, let's check out this example. We got 16 times x to the fourth times y cubed all over 2 times x to the fourth power. Remember, we can kind of break up our division, so we can write this as 16 over 2 times x to the 4 over x to the 4 times y cubed. So let's simplify each grouping. 16 divided by 2 is just 8. X to the 4th divided by x to the 4th. Remember, we can use our shortcut over here, where if I have the same amount, my exponent's the same on top and bottom, and it's the same base, then if I subtract them, then that's the same as 0. Anything to the 0 power is just 1. So I know that this is just going to simplify down to 1. And then I can just bring down my y cubed. So simplified, this would be 8 times y cubed.
All right, so we are going to try solving this tricky one right here. So I think the best place to start is to simplify maybe the top before we start using our division shortcut. We first have this piece right here with parentheses. So let's get rid of this exponent here, multiply that through, and use our shortcut right here so that we don't have a parentheses anymore. So we have to remember that this exponent applies to the 2 and to the x squared. Okay, so we know that 2 cubed is 8. And then using this shortcut right here, we can multiply these exponents together, which would be x to the 6th. Okay, so now this piece is simplified, so I'll just write the rest of what we have. So if we want to break up our fraction to the pieces that go together, because we can do that because they're all being multiplied together, we can say 8 over 30 times x to the 6th over x to the 5th times y to the 4th over y to the negative 1. Using our division shortcut here, we know that we can subtract these exponents to simplify them. So we will be left with 8 over 30, and we can simplify that to 4 over 15 if you just divide both pieces by 2. So 4 over 15 times 6 minus 5 is 1. So x to the 1 or just x times 4 minus negative 1. Remember, when we subtract a negative, it becomes positive. So we have 4 minus a negative 1 would be 4 plus 1. So y to the 5th. This is how we could write that simplified with no negative exponents and no exponent on the bottom.
All right, let's check out this example here where we have 15 over x squared times 1 over 45 times x to the negative third. Because we have parentheses here, they're just being multiplied, I can combine all my fractions together. Remember, when we multiply fractions, we multiply our numerators. So we can write this as 15 times 1. Over our denominators, we got x squared times 45 x to the negative 3. Because multiplication is commutative, right? 15 times 1 is the same as 1 times 15. I can write it in whatever order, and it does not affect my final product. So I'm going to write this. I'm going to group some numbers here. 15 times 1 over 45 times by 1 over x squared times x to the negative third power. So 15 times 1 is 15. 15 divided by 45 is 1/3. And that is being multiplied by this. We got 1 divided by x squared times x to the negative 3. If I look at just this part of my denominator, x squared times x to the negative third power, I can use my shortcut where I have the same bases. I can just add my exponents. So I can add 2 plus negative 3, which gives me negative 1. So I can rewrite this as 1/3 times 1 over 2 plus negative 3 is negative 1. So this would be x to the negative first power. All right, my goal is to rewrite this with no negative exponents. So in order to write this with no negative exponents, I need to change this. Remember our shortcut? I can take anything that's in the bottom of my denominator here, like 1 over x to the m, and if I flip my fraction, it's the same as the negative version of it up top. So I can rewrite this as 1/3 times x to the negative -1 over 1, which is the same as negative times a negative is a positive. So I can rewrite this as 1/3 times x to the first power. So whenever I have a negative exponent, I can just flip my fraction and it becomes a positive version of it. So negative exponent on the bottom, I can flip it and it just becomes a positive version on top. And that would be my final answer. 1/3 x to the first power or just 1/3 x.